Okay, let us now solve some basic questions based on the concept of area of sector and the perimeter of sector. First we will solve question number 7. It says find the area of a sector of a circle with radius 6 centimeter if the angle of the sector is 60 degrees. So it says that there is a circle and in this circle we have a sector there is a circle and in this circle we have a sector, let us say OAB, and this sector is subtending an angle of 60 degree at the center. Okay, so 60 degree angle is subtended by this sector and the radius of this sector is 6 centimeters. So I need to determine the area of this sector. We know the area of sector is equals to theta into pi r square upon 360 degrees. So what is theta in this formula? In this particular question it is 60 degree into pi is 22 upon 7 into radius is 6. So 6 square is 36 upon 360 degrees. This will be the value. Now 36 and this is 10. So this 0 and 0 will get cancelled and you will be left with 6 into 22 upon 7 centimeter square. Okay. So this is the area of sector. You can see it's a very basic question, just the application of formula. You are given with the angle subtended by the sector and also the radius of the circle. So just application of formula and final, and you will get the final answer. So this is the solution for 7th question. It's very easy. Then 8th question. Question number 8 says find the area of the quadrant of a circle whose circumference is 22 centimeters. Now here we will going to learn a new term. It says find the area of the quadrant of a circle. Now what is a quadrant of a circle? When a circle is divided into 4 equal parts. If I divide a circle in 4 equal parts, that is I draw a diameter like this and one more diameter perpendicular to this one. So this 2 diameters will divide this circle into 4 equal parts. This is the first circle, first part, this is the second part, this is the third part, this is the fourth part. If you take out any part from this particular figure, any part of this particular figure will be something like this. Okay, this is the part of this figure. This is known as the quadrant. Okay, this is known as the quadrant. Okay, that is 1/4 of the circle. Now this quadrant is subtending an angle of 90 degree at the center. Why? Because the 2 diameters that I have drawn are perpendicular to each other. So for this quadrant the radius of this circle is 22 centimeters. Sorry, not radius, it is the circumference is 22 centimeters. Let us say r is the radius and the angle subtended by it at the center is 90 degrees. So let us first determine the radius. Circumference is equals to 2 pi r. Circumference is 22 is equals to 2 into 22 upon 7 into r. So 22 will get cancelled. The radius is equals to 7 by 2 centimeters. Now to calculate the area of this quadrant, what will be the area of quadrant? Area will be area of quadrant will be, what is the quadrant? Quadrant is basically a sector in a circle which is subtending an angle of 90 degree at the center. Okay, so area of quadrant is equals to 90 degree into pi r square upon 360. So when you solve this will give you 4. So it is pi r square 22 upon 7 into radius is 7 by 2 into 7 by 2 into 1 upon 4. This 4 as it is that is pi r square upon 4. Okay. pi r square upon 4. So just solve this, 7 get cancelled, it will be 211 times. So 77 upon this 4 2s are 8. So 77 upon 8 centimeter square is the area of this quadrant, that is exactly 1/4 of the complete circle. So this is the solution for question number 8. Now the ninth question. Question number 9 says the length of the minute hand of a clock is 14 centimeters. Find the area swept by the minute hand in 5 minutes. Okay. So question number 9 says there is a clock in which the length of the minute hand, let us say this is the minute hand is the length is 14 centimeters. I need to calculate how much area will it swept in 5 minutes. So if I take into consideration the area swept by this minute hand, what I know about this minute hand? This minute hand completes one revolution in every 60 minutes. Okay, minute hand completes one revolution in 60 minutes. Okay, one revolution in 60 minutes, and since it completes one revolution in 60 minutes, how much angle do it swept in 60 minutes? It will swept an angle of 360 degrees in 60 minutes. This is what we can conclude. So what we can see is it swept an angle of, in 60 minutes it swept an angle of 360 degrees. So in 1 minute it will sweep an angle of 360 upon 60, that is 6 degrees. So in 5 minutes I can say it will swept an angle of 5 into 6, that is 30 degrees. This much angle it will swept in 5 minutes. So if it swept 30 degree in 5 minutes, I can see that if this is the current position of minute hand, after 5 minutes it will be somewhere here, that is 30 degrees of angle will be swept. Now since the radius of this or the length of this particular minute hand is 14 centimeter, I can see that this kind of figure we can draw in 5 minutes. This is 30 degree angle and the radius of this is 14 centimeters. Now what is this? This is a sector. This is a sector of circle whose radius is 14 centimeter and the angle subtended by this sector will be 30 degrees. Why? Because minute hand will travel 30 degrees in 5 minutes. So area swept by minute hand will be equals to theta into pi r square upon 360 degrees. Now what is theta? Theta is 30 degree into pi is 22 upon 7 into radius square. Radius is what? It is 14. So 14 into 14 upon 360 degrees. So just calculate this and you will get the area swept by this minute hand in 5 minutes. Okay. So this is the solution for 9th question. Again, this is also a very easy question, just the concept of unitary method that you have applied multiple times in your previous classes. We have used that concept and determined the final area. Now let us solve question number 10. Question number 10 says find the area of the sector of a circle with 4 centimeter radius and angle of 30 degrees. And it says also find the area of the corresponding major sector. You need to determine the area of corresponding major sector also as well as the minor sector. So question number 10, there is a circle whose radius is 4 centimeters and it swept an angle subtended by this is 30 degrees. Okay, this is the 30 degrees angle. So what will be the area of this sector? Area of sector will be equals to theta into pi r square upon 360 degree. This will give you theta is 30 degree into pi is 22 upon 7, or let us write it as pi only, into r square is 4 square upon 360. So you can solve this. This will give you 12. So 16 pi by 12, that is 4 4s and 4 3s. So 4 pi by 3 centimeter square. This is the area of this sector. Now which sector is this? This sector is the minor sector. So what about major sector? I can write area of major sector is equals to area of circle minus area of minor sector. What I have written is, if from this complete circle I subtract this much area, if I take out this much area, if I remove this much area, I will be left with the major sector. So from complete circle, from the area of complete circle, if I deduct this area, I will get the area of remaining circle. Okay, so area of circle is what? Remaining sector, that will be the major sector. This is the major sector. So area of circle is pi into radius is 4, that is 16. So 4 square minus area of minor sector, it is 4 pi by 3. Okay, so this will be the area of major sector. You can just calculate this, substitute the value of pi and solve this. You will get the final area of major sector. Okay, so these are some very basic questions that are based on the concept of major sector of a circle, sector of a circle. We have calculated the area of sector and we have also calculated the perimeter of sector. So after this we will understand the next concept, that is segment of a circle, and after the segment of a circle we will discuss some questions, and after that we will merge the two concepts and discuss some of the difficult questions that are related to this chapter. Okay, so first you note this, then we will continue. Okay, so we have understood the concept of sector and we have solved some basic questions based on sector. Now we will learn the next concept, that is segment of a circle. Now what is the segment? जैसा हमने सेक्टर के लिए कहा था, सेक्टर इज बेसिकली अ पीस ऑफ केक और अ पीस ऑफ पिज्जा. ओके, बिकॉज पिज्जा आप इस तरह से निकालते हैं, इस तरह से उठाते हैं पिज्जा का पीस, केक का पीस भी आप इसी तरह से उठाते हैं. बट इफ आई टॉक अबाउट पापड़, पापड़ को क्या कभी आप इस तरह से निकालते हैं? नहीं, पापड़ को हम हमेशा ऐसा तोड़ते हैं, इस तरह से, लाइक दिस, ऐसा. सो if I consider this as my papad, if I say this is my papad, इस पापड़ को हम कैसा तोड़ेंगे? ऐसा, इस तरह से, यू, like this. So जब मैं इस पापड़ को तोड़ूंगा, I will get this much piece of papad. I will get this much piece of papad, and this piece of papad is known as segment of circle. Okay, it's a very basic example. हमने इस पापड़ को इस तरह से तोड़ा, तो ये जो पीस हमारे हाथ में आया, ये पीस हमें सेगमेंट जैसा दिखाई देगा. इसे हम कहेंगे कि ये उस पापड़ का एक सेगमेंट है, इस सर्कल का एक सेगमेंट है. एंड here our task is to determine area of segment and perimeter of segment. We need to determine two things. First is area of segment and the next is perimeter of segment. Okay. So let us try to determine both the values. If I say that, let us say this is a circle, this is the center O, and from this center O I have drawn two radii A and B, OA and OB. So radius of this circle is, let us say, R. So OA will be equal to R and OB equal to R. Now if I join this this A and B point, if I join this A and B point, then I will say that this part is the segment of circle. Okay, this part which is formed by the circle, by joining the circle and the chord AB. You can see AB is a chord of this circle. So this part formed by chord, this part enclosed by chord and the circle is known as the segment of this circle. Now this is a segment and my task is to determine its area. Now how to determine the area of this segment? What I can see, what I can observe is, if this angle is theta, so if I observe this much part, if I observe this much part only, I can see this part is something like this. This is O, this is A, this is B, and this is the segment which I need to determine. This angle is theta, this is radius R, this is also radius R. So I can see that this segment is formed inside a sector. Okay, ये segment कहाँ पे बन रहा है? ये segment एक sector में बनता दिखाई दे रहा है इस तरह से. तो अगर मुझे इस segment का area निकालना है, तो let us try to think some relation between the area of this segment and area of this sector. एरिया ऑफ दिस सेगमेंट एंड एरिया ऑफ दिस सेक्टर के बीच में हम कुछ रिलेशन निकालने की कोशिश करते हैं. लेट अस से देयर इज अ पॉइंट ऑन दिस सेगमेंट इज P. सो आई विल से APB इज अ सेगमेंट. ओके, मेरा सेगमेंट क्या हुआ? APB. APB इज द सेगमेंट. APB इज नोन एज द सेगमेंट. ओके, नाउ इस फिगर को देख के आई कैन से एरिया ऑफ सेगमेंट APB is equals to area of sector OAPB. Okay, this is the sector OAPB. This is the complete sector. This, if I observe the area of this sector, this is OAPB. So area of segment is equals to area of sector OAPB minus area of triangle OAB. It means what I can observe is, if I want to calculate this much area, this area is equal to total area minus area of this triangle OAB. This is my triangle OAB. Okay, मतलब अगर मैं इस सेक्टर के एरिया में से ये ट्राइंगल का एरिया माइनस कर देता हूं, then I will get the area of segment OA, this APB. Okay, I will get the area of this segment. Now what is the area of sector? If I talk about area of sector, you know what is the area of sector? If this angle is theta, then theta into pi r square upon 360. This will be the area of sector. But what will be the area of triangle OAB? My triangle OAB is something like this. This is theta, this is O, this is A, and this is B. My triangle is OAB is something like this. Now, to determine its area, we will going to learn a concept of trigonometry, that how to write the area of a triangle in terms of trigonometry, in terms of sines and cosines. Just try to observe this. I am saying that if ABC is a triangle, I am saying that if ABC is a triangle, let us draw a triangle ABC. This is a triangle ABC, this is A, this is B, and this is C. In this triangle, I will say that side opposite to this A will be small a, side opposite to B will be small b, and side opposite to C will be small c. Length of side opposite to vertex C is small c. This you know very well. Now, I will say area of triangle ABC is equals to I can see this angle is angle A. Okay, this angle is angle A. I will say area of triangle ABC is equal to half AB into AC into sine of एंगल A. बड़े ध्यान से इस चीज को देखिएगा. मैंने कहा कि इस ट्राइंगल का एरिया मुझे निकालना है. एरिया निकालने के लिए मैंने इस ट्राइंगल के इस एंगल का यूज किया और इससे जुड़ी हुई एडजेसेंट साइड्स का यूज किया. उन दोनों साइड्स का यूज किया जिससे ये एंगल फॉर्म हो रहा है. सो एरिया ऑफ ट्राइंगल इज बेसिकली हाफ इनटू प्रोडक्ट ऑफ टू साइड्स एंड साइन ऑफ एंगल between the two sides, sine of angle between enclosed between the two sides. What I can see, AB and AC are forming an angle of A, sine of this angle A. So my area will be half into AB into AC into sine of this particular angle. Or I can write this area in other terms also, in terms of other angle also. Let us say we take angle B. Now एंगल बी फॉर्म किससे हो रहा है? एंगल बी इज गेटिंग फॉर्म फ्रॉम ए बी एंड बी सी. सो आई कैन राइट एरिया ऑफ ट्राइंगल ए बी सी इज इक्वल्स टू हाफ इंटू ए बी इंटू बी सी इंटू साइन ऑफ एंगल एनक्लोज्ड, दैट इज साइन ऑफ एंगल बी. In terms of angle B, this will be my area. Similarly, if I consider this angle, angle C, then angle C is formed by AC and BC. So I can write this area of triangle ABC in terms of angle C can be written as half into AC into BC into sine of angle C, into sine of angle C. This will be known as the area of triangle. This is the area of triangle in terms of angle A. This is angle. This is the area of triangle ABC in terms of angle B, and this is the area of same triangle ABC in terms of angle C. So what I can see is this area of this particular triangle can be written in terms of angle C or angle B or angle A. Okay, in terms of any of the angles of this triangle. So if I want to determine the area of this triangle, I can apply this concept here. I can see here I know this angle, that is angle theta. I know the value of this angle is theta. So I know this side OA is R, OB is also R. So if you relate these two triangles, this angle I know, that is theta. I know this AB side, this side is R. I know this side is again R. So area of this triangle, area of triangle OAB is equals to half into side OA into OB into sine of angle O or sine of theta. Okay, in place of angle O I can write theta. So triangle OAB, area of triangle OAB will be equals to half of OA is R, OB is also R, and this is theta. This is sine theta. So this will become half R square sine theta. This will be the area of triangle OAB. Okay, so just note down this particular part in your notebook as a concept. This is a concept of trigonometry that you will learn in your higher classes. This is the area of triangle in terms of angle A or angle B or angle C. I have used this concept because it will make our answer, make our solution more a bit easy, okay, to remember, to recognize. So you can recognize this particular formula. Now, as we have said, triangle OAB is equals to half r square sine theta. This we know. So if I know the area of sector and I know the area of triangle, I can calculate the area of segment. So directly I can write the area of segment as area of segment is equals to area of sector, which is theta into pi r square upon 360 degree minus half r square sine theta. This will represent the area of segment APB. Okay, this particular formula will represent the area of this segment APB, and you need to remember this formula also. You can derive this. This is not at all difficult. Okay, so we have the area of this segment. Yes, we have the area of the segment APB. Now, can we calculate the perimeter of this segment also? Perimeter of segment is equals to what? Perimeter of segment APB is equals to length of chord AB plus length of arc AB. Okay, if I add the length of chord AB, this is the chord AB, the length of this chord and length of this arc. So sum of this chord and this arc will give you the perimeter of APB. Now, what is the length of this arc? We have determined the length of arc previously. Length of arc is what? Length of arc AB is equals to theta into 2 pi r divided by 360 degrees. This is the length of arc AB. Now, now I need to determine the length of this chord AB. How I can determine the length of this chord AB? See, I can see that this OAB is a triangle in which O is this the center of the circle. If I draw a perpendicular from this center to this particular circle, this is the 90 degree, and let us say this touches the circle at M point. Now, this AM will be equal to MB. Why? Because perpendicular from the center to a circle bisects, perpendicular to a chord from center of the circle bisects the chord. Okay. So if this angle is 90 degree, I can say AM is equals to MB. Now, this will also bisect this particular angle AOB. So I will have this angle as theta by 2 and this angle as theta by 2. Now consider triangle AOM. AOM is a triangle something like this. This is 90 degree, this is O, this is A, this is M. AO is given as R. Now, can I calculate the length of AM? This angle is theta by 2. I can see AM and OA are related to each other in terms of sine theta. What is sine theta? Sine theta by 2, because it is sine theta, this angle is theta by 2. So sine theta by 2 will be equals to perpendicular, that is this is AM upon OA. This is OA. Okay. So the length of AM will be equals to OA sine theta by 2. Now, since AM and OM are equal, AM and MB are equal, I can write MB is also equals to OA sine theta by 2. Now what is OA? OA is equal to R. So length of chord AB will be equals to 2 times of r sin theta by 2. Okay, this will be equals to 2 times of r sin theta by 2. This will be the length of chord AB. Now as we have written, perimeter is equals to chord AB plus length of arc AB. So the formula for perimeter will become perimeter of segment will be equals to 2r sin theta by 2 plus theta into 2 pi r upon 360 degrees. This is the length of perimeter. Just try to understand how I have determined the chord AB, how I have determined the length of chord AB. I can see if I draw a perpendicular from center to this chord, it will bisect this chord. Okay, it will bisect this chord as well as it will bisect this particular angle also. So if this angle is theta, so it will be divided into two parts as theta by 2 and theta by 2. And if this angle is theta by 2, I have considered this triangle AOM. In this triangle, this is theta by 2, this is 90 degree and this is r, that is hypotenuse is r. So if I consider this angle, for this angle, this will be the perpendicular, this will be the hypotenuse. So this angle is theta by 2. So sin theta by 2 is equals to perpendicular upon hypotenuse. So from this I can get perpendicular or AM is equals to OA into sin theta and OA is equals to R. Again we have AM is equals to MB because perpendicular from the center to a chord bisects the chord. That's why I have written MB is equals to OA sin theta by 2 as well. From this, length of chord AB will be equals to sum of AM and MB. What is AM? It is r sin theta by 2. What is MB? It is again r sin theta by 2. So adding these two, 2r sin theta by 2. So we have the length of chord, we have the length of arc AB, and therefore we have the perimeter of this segment as 2r sin theta by 2 plus theta into 2 pi r upon 360 degrees. So this is the concept of segment of a circle. You can see it's a bit difficult compared to the sector. Sector is very easy. We can understand sector very easy, but determination of areas and perimeters of this segment is a bit difficult. So how you can remember? सेक्टर की बात आती है तो केक और पिज्जा, और सेगमेंट की बात आती है तो पापड़. ओके, पापड़ is the best example for this. Okay, so this is the segment of a circle. Now you can note this, then we will solve some questions based on this concept.